Hello, Integrated Math 1. Welcome to lesson 2.13b. So we're on day 2 of transforming our linear functions. So last time we realized that if you just translated up or down, basically we're just adding or subtracting that number to your function, and it created parallel lines. And we wrapped it up by realizing parallel lines have the same slope. We went all kinds of directions with that, and it was really cool. But we're going to take it in a slightly different direction today. So determining our goals, again, determining the effects of the graph on a linear function when f of x is replaced by f of x plus d. This is what we did last time, right? If you add 4, it goes up 4. If you subtract 2, it goes down 2, and the lines are parallel. But now we're going to focus more on this, a times f of x. What happens when you multiply your function by a number? Again, we're still going to be graphing those linear function transformations. We're going to show the intercepts. Again, we're going to identify those key characteristics, slope, y-intercept, what's going on, all that good stuff. And we're going to prove, we already did this last time, to prove that a translated line and its pre-image have the same slope and are therefore parallel. We already saw that last time. And we were writing equations with parallel lines last time. So now we're really focusing on what happens when we multiply our function by a number. So we already talked about a basic function. We said it's the simplest form of that function. And so what effect is this transformation of multiplying our function by a number? What effect is that going to have on the characteristics of our functions? So we are back to page 42. We're back to our, remember, AB, right, with coordinates at -8, -8, and we wrote that down. You probably still have it on your paper. I did the slide. So if we wrote that down, -8, -8, right? And then we were like, oh, and this guy here is 8, 8. And last time we were translating up and down, right? We added 4, subtracted 4. But now we're going to go to question 5 on page 43. We're just going to take this to the next level. I would like you to draw EF on the coordinate plane by multiplying all of the y coordinates by 2, not the x coordinates. I want you to multiply your y coordinates by 2, and then compare the 2 line segments, see how they're related. Hit pause, multiply your y coordinates by 2, and then hit play when you're ready to check your work. So my original a coordinate was -8, -8. But we said to multiply the y coordinate by 2. So not the x coordinate. X coordinate's going to stay the same. I'm going to multiply my y coordinate by 2. I'm going to double it. So it's still -8, but now my y coordinate is -16. And we'll do the same thing with b, right? We said that b was at 8, 8. We said we're going to leave the x coordinate alone, and we're going to multiply our y coordinate by 2. So that's still going to be 8, and of course 2 times 8 is 16. So if I were to plot these new points, which is what I'm going to do now, they don't even fit on my graph. They went like way, way off. Because -8, -16 is like down here. It's like way the heck off my graph. And of course, 8, 16 is like way up here, way the heck off my graph. Oh my gosh. And I connected them, and I tried to label them, but you can see everything went like way the heck out there. So E is down here, not that you can see it, and F is way up there. Not that you can see that very well either, but in fact here, let me scoot over. I might need to shrink myself. I just want to scoot. I'm going to scoot myself over. There you go. There's E all the way down there. Sorry, I got in the way. So what happened? What happened here? Let's talk about what happened. It looks like I just stretched this up here and I stretched that down there. So it looks like my new guy, my EF, is a lot steeper than AB, right? I mean, this would be a harder hill to climb. AB would be a harder hill to climb. EF would be an even harder hill to climb. It's definitely steeper than the original. Yeah. All right. What happens if you multiply your y coordinates by a -2? Can you do that? Can you multiply your y coordinates by a -2 and then draw it, and we'll call it GH, and draw that on your graph? Go ahead and hit pause to work this out, hit play when you're ready to check your work. So -8, -8, but I'm going to multiply that y coordinate by a -2. So it's still the -a, Negative 2 times a negative 8 is a positive 16. Okay, okay. I took my other coordinate, 8. Again, x coordinate staying the same, the x coordinate is fine. I'm going to multiply my y coordinate by a negative 2. So if I multiply these guys, I get a negative 16. Wow, so now when I go to plot my points, I need to go negative 8 to positive 16, which is way up there. And then I need to go positive 8 to negative 16, which is way down here. Call them G and H, because that's what they said to be the G and H. And check it out. So it's also steeper, right? It is definitely steeper. But now it flipped on us, didn't it? Stuff that was down here ended up above. So stuff that was below the x-axis ended up above it. And stuff that was above the x-axis ended up below it. So not only did we make it steeper, we actually flipped it. We reflected it over the x-axis. So the image is steeper, but we also reflected it over the x-axis. Stuff above is now below, stuff below is now above. We just want that stuff around. All right then. So let's consider how what we call dilations impact the graph of a linear function. So here I have my basic function, right? F of x equals x, there it is. And we listed off some points, negative 2, 2, negative 1, 1, 0, 0, 1, 1, 2, 2. So we have our points. I would like you to, it's going to be changed by a factor of 4. Okay, so we're going to create a of x by a factor of 4. You know, it says to sketch the graph and then complete the table of values, but for me personally, when I have a factor of 4, which by the way, factor of 4, I'm going to find my pen here. Factor of 4 means that I'm going to multiply, right? Factors of 4, multiply, and we're going to multiply the y coordinate by 4. This is actually what we just did with the 2 and the negative 2. But now we're going to do it with 4. So I find it's easier in this case to do the table first and then graph it. So go ahead and hit pause, fill out your table, or change it by a factor of 4. So you're going to multiply your y coordinates by 4 and then graph it. So hit pause, work that out, hit play when you're ready to check it. So as I said, we're just going to be like times 4, times 4, times 4, times 4. This is all we're doing. When I have a factor of 4, we're just multiplying all our y coordinates by 4. So negative 2 times 4 is a negative 8. Negative 1 times 4 is a negative 4. 0 times 4 is, well, 0. 1 times 4 is 4. And 2 times 4 is 8. Yay! And that makes it so much easier to plot these points, right? Because now I have the points. So negative 2, negative 8. Negative 1, negative 4. 0, 0, 1, 4, 2, 8. And of course, that makes it a lot easier now that I've got my points. I can draw my line. Good job. Oh, I should label it A of x. I labeled it. There we go. So now that we've done this, and we did a good job, yes. Can you identify the slope and the y-intercept of our new function? We said earlier, yesterday or last time, we said that f of x equals x. I can't even. We said when f of x equals x, we said our slope was 1 and our y-intercept was 4. Not was 4, it was 0. Goodness gracious, what in this happening? So now that we've done that with f of x, what about a of x? Can you tell me about a of x? What's our slope? What's our y-intercept? All that good stuff, and then write an equation for it. Go ahead and hit pause to work this out. Hit play when you're ready to check your work. So the y-intercept didn't change. I can see my y-intercept is still here at 0, but let's talk about that slope, right? On our f of x equals x, it was up 1 over 1, up 1 over 1, but check it out. Now my slope is up 4 over 1, isn't it? So I had to go up 4, so up 4, and then over 1. So if I do rise over run, my slope is 4 over 1, or just plain 4. So my slope is now 4. My y-intercept, like I said, didn't change. My y-intercept is still 0. So if I were to write the function for a of x, I would say a of x equals 4x plus 0. Or actually, we don't need the plus 0, do we? So I guess I could just write it as a of x equals 4x. We don't actually need the plus 0. Okay. Let's make it trickier. I want you to sketch b of x, and we're gonna suppose our output values are changed by a factor of 2/3. Again, I would do the table first and then the graph. Go ahead and hit pause to work this out. Hit play when you're ready to check it. So again, I'm just going to take each of these and I'm going to be like times 2/3, times 2/3, times 2/3, whoa, times 2/3. Sorry for the bad handwriting, times 2/3. When we do this, don't freak out if there's fractions. We just multiply this with the numerator and we keep our denominator as 3. So -2 times 2 is -4. 2 is -4/3. -1 times 2/3 is a -2/3. 0 times anything is 0. Okay, thank you for being simple. 1 times 2/3 is, of course, just 2/3. And so if we do 2 times 2/3, 2 times 2 is 4, and it will be over 3. Now, plotting these points gets tricky, but don't freak out. Remember that you could think of this as -1 1/3, 2/3, 0, 2/3, and you could think of this as +1 1/3, if that helps you graph at all. So we're going to go -2, and then we're going to go down 1 and a little bit more. Not much. -1, and then we're going to go down 2/3. We're going to quite get to 1. 0, 0. That's easy. You can do that. 1 and 2/3, so over 1 and not quite at 1. We're only going up 2/3. And then 2 and 4/3, so that's 1 and a third. This isn't the best ever, but you get the idea. If I were to connect these up, it would look like this. And we'll call it b of x. This is a little different. All the others we've done, we got a steeper line. For this one, we actually got a less steep line, didn't we? That's interesting. So, can you please identify the slope and the y-intercept of b of x, and then write the equation for the function b of x in general form. Go ahead and hit pause, work that out, hit play when you're ready to check. So I can see the y-intercept didn't change. Let's talk slope for a moment. So from here, I'm going to pick some easy points here, and it looks like I've got an easy point right there as well. Oh dear. Oh dear. So it looks like I went up 2, and then I went over 3. Oh, so rise over run, that means my slope is 2. Wait a minute, I feel like we've seen that before. So my slope is 2/3. My y-intercept didn't change, it's still 0. So that means if I were to write b of x in general form, I have 2/3 x plus 0. Except I don't actually need the plus 0, so I've got b of x equals 2/3 x. Okay. Let's do another one. One more. Let's multiply our outputs by a factor of -4. Hit pause, do your table, do your graph, and then hit play when you're ready to check your work. So I did my table first, and I, again, times -4, times -4, times -4, times -4, times -4. So I'm just multiplying everybody by -4. So this would be a +8, a +4, 0, a -4, and a -8. And of course, if I pull up my points, I've got -2, +8. I've got -1, +4. 0, 0, 1, -4, and 2, -8. And if I connect the dots, oh, there it is. Oh, and I should label it C of X. And again, one more time, identify the slope and the y-intercept of C of X, and then write the equation for the function c of x in general form. Hit pause to look it out, hit play when you're ready to check it. So you probably know the dealio now. You've probably already noticed if I go from here, oh dear, if I go here, and I like using 0. Let's see, it looks like I have another good point right there. It looks like this time I had to go down 4 and then over 1. So that means my slope is going to be negative 4 over 1, also known now, negative 4. Again, does the slope remember? So my slope is negative 4. The y-intercept, it still hits at 0. That hasn't changed. So c of x equals negative 4x plus 0. Except I know, we don't need the plus 0. So c of x, I could also write it as c of x equals negative 4x. So it looks like my slope was affected this time, not my y-intercept. But some strange things are happening here. So for the basic function f of x equals x, the transform function y equals a times f of x shows what we call a vertical dilation of the function. A dilation just means you're either stretching it or shrinking it. And this dilation affects the output, or y values, of the function. So if the absolute value of your a is greater than 1, then your graph stretches, then your graph is vertically stretched. If a is greater than 1, it's going to be vertically stretched. If your a value, the absolute value of your a value is between 0 and 1, then our graph vertically compresses. Think of it as shrinking, but we'll use the word compress because that's a better answer. If your a value is negative, if your a value is less than 2, then it gets reflected across the y-axis. Or not y-axis, x-axis. Interesting stuff. Can you just take a moment and compare, can you find f of negative 1 and c of negative 1? And how did the transformation affect the values at x equals 1? Go ahead and hit pause, find each of these, and then and talk about what happened, and then hit play to keep going. So f, of course, f of x equals x. So if I plug in a negative 1, then I get negative 1. C of x was negative 4x. So if I plug in a negative 1, negative 4 times negative 1 is a positive 4. So the vertical dilation multiplied the value of the function by negative 4. It's fair. That's what's going on here. So can we just consider a few more things? I've got a few more. Now I'm going to start messing with you guys. So you know that if you do f of x plus something, it's going to push it up. If it's f of x minus something, it's going to push it down, right? But now you also know that if you multiply by something with an absolute value greater than 1, then it's going to vertically stretch your function. You know if you multiply your function by something with an absolute value between 0 and 1, like a half or 2/3 or whatever, it's going to compress your function vertically. And you know if you multiply your function by a negative, it's going to reflect over the x-axis. So I have several of these problems for you to do. Of course, I can only show one at a time on my graph because I'm going to try to graph all of these. Oh my goodness. So I can only show one at a time, but go through these. Can you please describe the transformation? What happened? What is happening? What is happening? Describe the transformations performed on f of x to produce g of x. What is happening? Let's see if you can graph it. Hit pause. Work these out. I've got A, B, C. I got a couple of these. Hit pause to work these out, and then hit play when you're ready to discuss them. Okay. So I notice, hey, we're multiplying by 2, so it's going to vertically stretch by a factor of 2. I also notice we're adding 7, so it's going to shift everything up. It's going to translate up 7 units. So we do need to make sure we mention both of these things. That 2 is going to stretch it. That 7 is going to push it up. And of course, if this is f of x equals x, then that means g of x is going to be, well, f of x is x, but it's going to be 2x plus 7. So if I graph this, I know I'm going up 7. But now my slope, instead of being 1 over 1, my slope is going to be 2 over 1. So I need to go up 2 over 1. And then I can totally, bam, there we go, I can totally graph this thing. Sorry, I did have that there. That's okay. I know it always has, so it's all good. There we go, now it's great. How'd you do on the next one? Now that you've seen this one, how'd you do? Well, I say it's being multiplied by 3. So again, 3 is greater than 1. 3 is greater than 1, so we're going to stretch. We're going to vertically stretch by a factor of 3. I see a minus 7, so it's going to translate down 7 units. So vertically stretch by a factor of 3, I'm going to translate down 7 units. So again, I'm just going to take this little guy. We said f of x equals x. So fine, that means it's 3 times x minus 7. So now my y-intercept is at negative 7. Now I'm going to go up 3, 1, 2, 3 over 1, and connect the dots. Yay! Oh, and I should label it. I like to. Nice. What about this one? 1/3 is less than 1, isn't it? If I multiply something by less than 1, it's not getting bigger. If I multiply something by 1/3, it's getting smaller. So I'm going to say this is vertically compressed by a factor of 1/3. Ooh, and the plus 2 means it is getting translated up 2 units. Which means if I do my function, because I know that f of x just equals x, so I can substitute that in. So that means g of x equals 1/3 x plus 2. So I have a y-intercept of 2, because we did push it up 2. And we did squish it. So instead of going up 1 over 1, I'm going to go up 1 over 3. Then I can connect those. And label it g of x. Oh my. So look at that. We wrote the equation in general form, and then we used it to help us graph. Hey. Oh, I guess I did have one more. D. Ooh, D. Okay, D. Let's talk D. If you're multiplying by a half, that's definitely getting smaller, right? It's less than 1. You're cutting it in half. So it's not going to be vertically stretched. It's going to be vertically compressed by a factor of 1/2. Ooh, and the minus 3 means it's going to be translated down 3 units. Awesome. I find it easier to write the equation before I graph it. So again, I know that f of x equals x, so I can just pop an x in there. So that means I have g of x equals 1/2 x minus 3. So my y-intercept is a negative 3. Oh dear. My new slope is up 1 over 2, and I connect the dots. Hey! Oh, and I call it g of x. Yep. Yep. Do I have more? There is more. Ooh. A negative. You know, if I'm multiplying by 1, it's not going to stretch or compress, is it? Right? I mean, if you're multiplying by 1, it does nothing gets bigger or smaller. It just is what it is. However, I'm multiplying by a negative. So it is going to reflect over the x-axis, right? Positives become negatives, negatives become positives. And we're translating down 4 units. So let us write our function. G of x equals negative 1x minus 4. Fine, my y-intercept is at negative 4. And now we're going to go down 1 over 1. So down 1 over 1. Grab my straight edge, label it g of x. There you go. All right. Whoa, too far. There's more. All right, negative 2/3 times f of x. 2/3 is less than 1, so it's going to vertically compress. Vertically compress by a factor of 2/3. It is negative. Oh, sorry. It is negative, so it is going to reflect over the x-axis. Positives become negatives, negatives become positives. Oh, and the plus 5, we're pushing it up 5. All right. So it reflects over the x-axis, it's compressed by a factor of 2/3, and it's translated up 5 units. Let's write our general form function. So x equals negative 2/3 instead of f of x. I can replace that with x and plus 5. So if I graph this, I have a y-intercept at 5. And it looks like I need to go down to and over 3. And then connect the dots. Boom. And label it. Boom. So when a function is both translated and stretched vertically, the resulting function can be written in the form of a times f of x plus d. Where d represents the vertical translation, right? D is the up and down, and a represents the vertical dilation. So a is the I stretched it, I compressed it. So how does the change in a value affect the slope of your function, and how does it affect the y-intercept of the function? Hit pause, write down your thoughts, hit play when you're ready to check your work. So I said that the a value is multiplied by the slope of the function, but the a value doesn't actually affect your y-intercept. What about the d value? How does the changing d value affect the slope of your function? How does it affect the y-intercept of your function? Hit pause, write it down, hit play when you're ready to check your work. So I noticed that the d value doesn't affect the slope at all, but it does get added onto the y-intercept of the function. So the d value does affect your y-intercept, doesn't affect your slope. As always, guys, I hope you found this helpful. I hope you found this useful. If you have questions or concerns, please email me or come talk to me. I'm around at lunch. I'm around during office hours. I'm around. Come talk to me. And I'll see you guys later. Bye.